I am actually, by training, a historian of science. And that points you already to something very significant about the historical moment that we're in, the transformation that we're going through, as the digitalization of so many realms of life has reached the stage that it is starting to transform educational programs and universities at a scale that is actually historic. And one of the reasons why I have spent roughly the last 7 years of my career at UC Berkeley developing opportunities for what we would now call data science education is because I see, as you do, how transformative this wave is that is reaching over us, and trying to find ways to adapt our existing institutions of higher education to meet those needs. So I'm going to start with, I'll call it a view from Berkeley, in the sense that we've been watching it here at Berkeley, observing it, not saying that there is one right path to doing data science education in higher education, but having watched it up close and seen just how fascinating and transformative it can be. I'm going to show you a picture of the first day of class in our freshman level Foundations of Data Science class. We had 1,300 students and 300 more who we didn't even have space for. The demand for data science education at Berkeley has gotten to the point that we no longer have lecture halls big enough to meet it. And we're meeting in the rooms where concerts are given. I want to give you some sense of what led to this moment and where it's going, and what lessons those of us who have been living it for the past years have drawn from it. Because I expect that this change that we're seeing at Berkeley will find its way to wash over institutions all around the world, because the need for education in this field of data science and data analytics to meet the workforce needs, as was mentioned just before, is going to hit all of us. We happen to be at an epicenter at Berkeley because of the particular character of the institution. But some of the things that we've learned and some of the experiences that we've gained, I hope, can be helpful for other institutions as they each find their own way through this landscape. Because there is no royal road. Every institution will do it differently, but we can all learn from each other and create communities of practice around this. And I'll tell you a bit about how that is playing out, not just at Berkeley, but in the United States at large. So if you look across the American national scene, if you take a look at whether it is over on the side of the massive growth that we're seeing in computer science enrollments that has set in the last roughly 3 to 5 years, you look at the demand for a data science workforce, you look at national level, National Science Foundation initiatives placing the data revolution as the first of the 10 great ideas that the National Science Foundation is investing in. Or if you look at private foundations who are investing in transforming data science into the foundations of all of the sciences itself, as in the Moore and Sloan Foundation's Data Science Environment Initiative, you can see how across the different fields of research and education in the United States, this need has been signaled for roughly the past 5 to 8 years and is now starting to get real traction to the point where transformations are happening not just at the individual level of institutions, but starting to reach across them. Berkeley's scenario of approaching this started actually in 2 different places, and one of them was undergraduate education. Now, you may know Berkeley as a high-level research university, but one of the great inspiring things about this same university is that it is invested in training large numbers of California students in order to meet workforce demands. And because California is one of the epicenters of the data science revolution, it was already clear to us back roughly 4 years ago that we needed to develop what we described as a comprehensive curriculum built from the entry level upward. That is, starting with people who have just graduated from California high schools and bring them into this area of data science and meet varied kinds of needs that they would have for what we were calling data fluency. Some might cash it out as data literacy, and now it makes the bridge over to data science. So we start from the foundation up and build connections out to application domains, where students' interests lie much more often than with the conceptual foundations or technical rigor of the field itself. We're starting from students' interests in real-world issues, not just their job prospects, but also the fact that they understand that data can contribute to solving social problems, and to find a way to engage them and draw them in, starting with their interest, and then build it from that freshman level upward. So the way that we've broken that out at Berkeley is to develop a whole palette of different kinds of educational opportunities in the data science area, where we do start with the course Data 8 at the center here, the foundations of data science. But we've built a whole constellation of other opportunities around it, other data science courses, connector courses that reach out into application domains that I'll talk a bit about some examples of. What we call modules, which take existing courses in fields like sociology or environmental science and bring data science modules into them. Develop entirely new courses to meet something that is often called data ethics, but we construe even more broadly as human context and ethics, the societal transformations going on in a datafied world. And also develop an online offering on the edX platform for MOOCs that will not only allow us to provide these kinds of course experiences free all around the world, but also to bring the Berkeley curriculum into other California schools and into our community colleges, which provide transfer pathways to students to start from relatively modest backgrounds and rise up to the University of California. So a lot of this is organized around curriculum, and that has been so essential to our getting traction in the California higher education landscape. There is another part of it, however, that does start from the research side. And so the initiative of the Moore and Sloan Foundations as funders for data science environments back in 2013, very, very prescient. Seeing already 5 years ago how transformative data science techniques would be for astrophysics or natural history or sociology, and spurring institutions with relatively large grants, a total of about $37 million, to invest in building environments where data science scientific pathways would ramify out through other parts of the academic landscape. My path through this has been, I was called upon in 2014 to co-chair the Data Science Education Rapid Action Team, in part because as a historian of science who was previously trained in theoretical physics, I have the competence to speak with statisticians, computer scientists at a very high level, and translate what they do into terms that the rest of the university can understand. That is a sort of powerful social force in bringing together people across the university, this translator work. And data science is such a spectacular example of how translation and integration across the university can lead to incredible institutional outcomes. So co-chairing the Data Science Education Rapid Action Team, rapid inside a university means we were given a 6-month timescale. We actually met the 6-month timescale, and then we went out and started building the courses that we recommended before the university even asked us for a budget. This was not a terribly planful enterprise, but the idea of recognizing the need and going after it, and as faculty members, creating new courses that would serve the students' needs, seized a bunch of us in this area. And so we started designing the Data 8 Foundations of Data Science course as soon as we finished our committee work. And we just started offering it and only began with 100 students in the fall of 2015 and just grew it and grew it and grew it. There's never been a course that has grown at this pace at UC Berkeley in its history. And it's been incredibly challenging for the institution to keep up because, as you know, universities' budget cycles tend to take 1 or 2 years to adapt to any changes. And so we've just been forcing the institution, in part through showing them the student interest, to make the adaptations to let this change go. Now, the rest of this goes into sort of deeper institutional details. I also chaired the faculty advisory board that created the proposal that has now been realized as a new division of data sciences, which is first of all, the host for this undergraduate curriculum, the first new dean created at UC Berkeley in about 25 years, recognizing that the breadth and the depth of data science actually calls out for institutional transformation. And so within this new dean level entity, there is the education program, but we are also starting to do institutional reorganization around data science, bringing computer scientists and statisticians and domain faculty together. And just so that you have a sense of the people who are involved, this is the core of the team. We have Startup Space. Our dean over there on the very far right is former chair of electrical engineering and computer science at Berkeley, David Culler, and he has been leading us through this process together as we build the foundations for the new data science division. So let me talk more specifically about Berkeley and the curriculum that we've brought out here and give you different aspects on it so that you can think through what pieces of it particularly resonate with the needs in Germany or in your own institution. Berkeley is a relatively large public university, 30,000 undergraduates, roughly 1,500 tenure track faculty, a rather high level of students per faculty for American elite universities. We have a particular cluster of strength in computer science and in statistics, and particularly in the intersection between those two, in machine learning and now into artificial intelligence, that's been built up over several decades. But the strength of Berkeley isn't just on the technical side, it's also in the fields of the social sciences and the humanities and the arts, and all across the sciences. So there is no place at Berkeley that is particularly weak. It happens to be known on the technical, the STEM side, but every part of the university feels very strong and wants to be engaged in data science. The university also has a very strong sort of bottom-up, startup feel to it, in part because, as we tell the story, we've been under-resourced by the state of California for roughly the past 20 years. And so being so close to Silicon Valley and having professors who are entrepreneurial both in their research and also in their educational efforts has made us unafraid to just go and build things, try them out, and then see how fast we can scale them. If any of you know the history of Berkeley computer science, their motto is, this will sound a little unkind, Stanford builds companies, Berkeley builds industries. And they tend to do these sort of invisible underlying infrastructure of each new wave of, whether it is operating systems or networking, or Berkeley will tell you a story about the web that doesn't start with 2 graduate students at Google, that starts with search at Berkeley. This is a group of people who really have a very strong sense of their mission to provide infrastructure for others and then to go and do it at scale. And the fact that Berkeley, in fact, does supply more technical graduates and engineering graduates to Silicon Valley is part of our understanding of ourselves. Because we are large and because we perform at a high technical level, you can find Berkeley graduates all throughout the managerial levels of Silicon Valley companies. So let's go back to the Foundations of Data Science class. This class is aimed at freshmen and sophomore students of all fields of study with no prerequisite knowledge required. No previous experience with computing at all. No previous statistics. The level of mathematics that we expect is what we call high school algebra, so no calculus is expected. And it has drawn large numbers of students, in part because it teaches both statistics and computing through the lens of each other and makes them interesting by working with real-world data. In some ways, this is just a better way to teach statistics, by recognizing that when you can compute on data, you can understand things conceptually by simulating much better than you can by writing down formulas. But it's also a better way to teach computing because it actually engages students in finding out things about the world that they're interested in. We often choose examples from areas of social justice or environment because the students who come to us want to find ways to learn more about that part of the world. And we do an awful lot of work also to make the technical platform that they're working on invisible to them. All of the computing that they're doing here is done in a browser. They can have, you know, a Chromebook. And all of the cloud infrastructure that's behind it makes it possible for them to just jump into doing computing on data without installing software on their notebook, no command line, nothing of the deterrent that computer science classes can put in front of them. It's also fairly conspicuous that the class is over 50% female. And so given that we aren't quite up to the level of the university as a whole, which is 53% female, but we're getting there. And we think that this is a wonderful way to draw students into computing as well. So if you're interested, I'll make these slides available to sort of walk through what it is that you can do in this intersecting space between computer science and statistics, where you teach statistical concepts by simulating on data. We teach freshmen the bootstrap because you understand better what underlying statistical concepts are when you just get the intuition out of doing it over and over and over with the computer in real time in front of you. But you also learn the computing. You know, you learn your Python by learning how to write code that does interesting things in the world. And then you want to make sure that you bring all of that content down to the absolute minimum, conceptually structured. This class was designed by a very high-end machine learning expert, Michael Jordan, who was working with extraordinary teachers to really conceptualize the core of what data science should be at this level. And then make it possible for them to go on and see the complications later, to know that there's something more to it. So for instance, if you really want to understand what the null hypothesis is, sampling is a wonderful way to actually do it. So some student observations about the course. I took a statistics class before. I hated it. I walked into this class and I realized it was different, and we excised some words that we wouldn't use in public about, you know, how students would express how much they hated it, the previous class. But they loved the conceptual approach. And on the computer science side, this was a vastly different approach to programming, much more engaging for students who didn't come in with this sense of themselves that they were going to be computer scientists or programmers. And the interdisciplinarity of it, both in the student body and in the course itself, is a draw for the students who we're seeing are increasingly looking for programs of study that are integrative, that are not the traditional disciplinary programs that my generation or perhaps yours were trained in. So moving quickly through the rest of the program, alongside Data 8, running simultaneously, we've developed about 25 or 30 connector courses, which are also no prerequisite courses in application domains taught by faculty and instructors in those areas that pick up particular questions that are enabled by data science and allow the students to take these classes alongside Data 8. So legal studies, taking the measure of the justice system, cognitive science, data science, and the mind, sports analytics for those students who want to understand how it is that basketball hotshots are performing. All of these were developed just like Data 8 was developed by faculty just in their regular course of study. And we find that students like the connectors as much as they like the foundations class. It gives us, as a university, some structural capacities to provide one big foundations class that other courses can use as a platform. So we're not deploying all our faculty resources teaching and reteaching computer science and statistics. But the students get the benefit of working hands-on with problems that they care about. If you go upward, we've now gotten up to the sort of what we call the junior level of Data 100 Principles and Techniques of Data Science, which is a much more a data science course than the foundations course is, where it works with actual real-world data sets, has students do the entire data life cycle from generating the data to cleaning it, to exploring it, to analyzing it, to drawing conclusions from it. It is only 800 students now, and we're going to have to scale it to at least twice that size because we expect this will be the foundation of both the data science major and the minor, which will open up in the next year and become very instantly one of the two largest majors and minors the university can offer. So the major, we think of it as having, and here we really are getting into areas where different universities, especially in the United States, are doing different versions of programs of study. The Berkeley version, interestingly, is not incredibly technical. It is not meant to prepare students to go immediately into data science jobs in Silicon Valley. It's preparing them to go on and become scientists in other domains, or preparing them in order to do another year of study to get a master's degree to become data scientists themselves. And the structure of our curriculum here starts from the foundations course and the integrative classes, Data 8 and Data 100 that I described, but puts much more emphasis on the computational and inferential depth in line with students' own desires for what they want to work on. So students, of course, have to take a machine learning course and a probability course, but whether they take databases or whether they take time series after that is up to their own sense of what their future is going to be. A student who wants to go on and become an astrophysicist is going to take time series, whereas a student who wants to go and work in the Valley is probably going to take databases. And then there's also a strong integration of domain classes that I'll speak a little bit about with our domain emphasis area, and the human context and ethics, which is not only integrated into the foundational gateway classes, but also called out as a separate expectation. Now you'll notice there are no capstone projects in here. There are no built-in team projects called out as a particular, closing experience at the end of the major. We would love to do that, but we can't do that at scale. So if you imagine putting 800 students through data science capstones with the resources that Berkeley has for faculty, we see we can't do it. And so that's where we have to actually generate the student interest to develop their own internships and their own capstones. It's one of the limitations of being an underfunded public research university. But the entrepreneurial students are also part of the culture here. Okay, so examples of the domain emphases really stretch across all of the application domains that data is transforming. This is part of the more Sloan stimulus to us. And it's been really interesting to watch how my computer science colleagues have recognized how powerfully the curriculum can be anchored in domains outside their own disciplinary specialty. It's been a bit of an adjustment for many of them to seed leadership of this area, to share it with faculty in application domains, as we actually take to heart the notion that data science combines computing with statistics, with domain expertise, and then figuring out how institutionally to make that work. We also have a number of new human context and ethics courses, which are meant not just to generate student knowledge of questions like privacy and governance in classical data ethics fashion, but to help them come to grips with the fact that they will be joining parts of industry and parts of public life that will be transforming their own lives and the lives of others sharing in their own society. As these human context and ethics classes have been spun up in the last 6 months, we've had to work through everything from Cambridge Analytica to election manipulation to Google and Facebook being called before the American Congress to testify about the detrimental impacts of data science on society. So these classes are ones that also open up those societal transformations. I happen to be teaching the history version of a human context and ethics of data class, which is a very big stretch for me, but because I realize that the need is there, because I have 200 students who are clamoring to take a data ethics class, I've put my own time into that. Finally, I should talk a bit about transformations going on in fields all throughout the university enabled by data science. We have about 30 to 50 students who work with us who have gone through Data 8 and Data 100 and know more about data science than just about any faculty in the rest of the university, who are now going out and helping other professors import data science into their courses, because the faculty have the desire, but they don't have the time or the skills, and the students, in a somewhat frightening way, are able to lead the way here. So you can see, for instance, a sociology course on social inequality has worked with sophomore and junior students coming out of our classes in order to bring these skills of data science to students in sociology or ethnic studies or psychology. And the sort of bottom-up nature of this transformation has been startling for both the students involved, who feel empowered, and the students who they're working with, who they're serving. This is an example from a sociology class that looked at local collection of data about wealth and poverty in the San Francisco Bay Area. Another of our big modules courses has been stigma and prejudice in psychology, looking at implicit bias and health outcomes that are differential by race, in a part of the university where engaging with data and with computing was seen as not only uninteresting, but hegemonic and problematic methodologically. So you see the power of these to reach across. And finally, you can see how this community across the United States is starting to come together around data science education, not just, coming out of Berkeley, but faculty in many universities are now networking and sharing curricular materials and finding ways to form communities of practice to how to teach this material, how to teach it well, and how to teach it at scale. I've put some links that will be available in the slide if any of the things that I'm going to show you are valuable. For instance, how do you offer the computing infrastructure that lets you simultaneously serve 1,300 students at a time? There's an entire technological infrastructure under here using Jupyter Hub and Kubernetes that Berkeley has ended up being on the front lines of pushing forward, in part because of the co-location of the Project Jupyter team at Berkeley. So there is all kinds of technology that needs to get built for education in this area, just to make it possible for students to compute in a browser without installing software themselves. So if you look across the country, you'll see that this is not just going on at high-level elite research universities. It is going on at liberal arts colleges. It is going on at historically black colleges. It is going on at community colleges. It is going on in just about every campus of the University of California system, not just the one in the Bay Area. And so we're really looking forward to the the convergence of a national community of practice that may map onto what you're going to do here. So as I step back, the conclusions that I would draw if I were trying to seed thoughts that could be valuable for the effort of this task force here in Germany would be to recognize, first of all, that there is no royal road. There's no one way. Berkeley happened to do it the way we did, in part because of our local situation, because we have computer science and statistics at the core of our effort. But there are other ways to do it as well. And each place will do it, I think, most well based on its natural strengths. But even with those differences, there is no way to do data science well by being in a silo, by being focused on your existing discipline and making that the center. Because the nature of the field is to draw us all together. And that is challenging and hard to work through, and there's so much translation and patience that's needed. But yet our experience at Berkeley has been, it actually pays off. There is so much intellectual ferment in working with colleagues who are in different parts of the disciplinary spectrum. And we're also seeing that it's bringing new ways for computer scientists to think about their own field. And I don't just mean how to teach computer science. I think you might see the emergence of a new kind of computational thinking that is much more centered on the data than previous versions of computer science have made clear. And as I watch my computer science colleagues grapple with this, when they hear that Intel says they're becoming a data company, they realize that's going to bring changes to programming languages, to all sorts of systems design, to thinking about data. It's going to give computer science new fields to work with. Now, this field is changing in time as we go. It's very hard to design for now and have the same curriculum work 5 years from now. But that is part of the excitement about it as well. This field will not get stale. And that's one of the reasons why after 8 years in it, I'm still at it. But in order to take that reality into account and to really recognize the transformations in the workforce, we're going to all have to come to grips with the scaling problem. If there's one thing that's been particularly hard at Berkeley, it has been how to go to scale. And I think everyone will confront that in their local setting as well. And finally, as a closing note, this isn't a technical problem. This is a social problem. How to get the collaborations across the disciplines, across the institution, in order to bring this into being has been both the most exciting and the most sort of continually hard to work through for those of us who were trained in classical disciplines and now realize that even at a place like Berkeley with its strong disciplinary expertise, we have to rework, and at the national level as well.